Hi guys, we are from Group 6. We are going to present about inheritance and drug response. Do enjoy this video presentation and grab as much knowledge as you can. Let's start with the very basic sharing on the role of inheritance of individual variation in drug response. First of all, do you have any thoughts on what is pharmacogenetics and pharmacogenomics? I am going to explain pharmacogenetics first, which refers to how variation in one single gene influences the response to a single drug. Whereas for pharmacogenomics is the study of how all of the genes can influence response to the drug. However, this video only focuses on pharmacogenetics of drug metabolism and the role of inheritance in the individual variation in drug response. The pathway of drug metabolism comprised with two phases, which are phase 1 and phase 2. However, we are going to focus on the inheritance of individual variation in a drug response for each phase. In phase 1, the early development of pharmacogenetic study is due to hydrolysis process of muscle relaxant succinylcholine by enzyme of butyrylcholinesterase. However, there is 1 in 3,500 people who is having a typical form of butyrylcholinesterase enzyme and thus is unable to hydrolyze the succinylcholine. As a result, it prolonged the drug-induced muscle paralysis and consequent apnea. CYP2D6 is one of the members of cytochrome P450 enzyme. It is the most important enzymes that catalyze the phase 1 drug metabolism. CYP2D6 genetic polymorphism results in poor, intermediate, efficient or ultra-rapid metabolizers, which means that the individual variation exhibit different pharmacokinetics and therapeutic effects of drug. For example, 5 to 10% of white subjects had an impaired ability to oxidize and metabolize the antihypertensive drug debrisoquine as well.
Pharmacogenetics and phase 2 drug metabolism. The examples of pharmacogenetics of phase 2 drug metabolism involve the N-acetyltransferase 2 gene polymorphism that is responsible in pharmacogenetics variation of isoniazide. As a result, most Asians are rapid acetylator, while most Caucasian and Japan are slow acetylator. Slow acetylation may lead to higher blood levels of the drug and thus increase in toxic reaction. The second example is the polymorphism of TPMT. Thiopurine drugs, for example like Mercato thiopurine, were metabolized by thiopurine acetyltransferase. Genetic polymorphism of this TPMT will affect the TPMT enzyme level and cause lower of enzyme activity of TPMT that lead to the accumulation of 6-thioguanine. The accumulation of this 6-thioguanine can cause the thiopurine-induced toxicity. So in conclusion, the advancement of pharmacogenetics may help physicians to be able to choose the best individualized therapy based on inheritance in genetic variation. Thank you.